Good morning. This is Professor Shannon Gracie. We'll be working out of the Sullivan and Sullivan Precalculus Enhanced with Graphing Utilities text. And today we'll be focusing on solving polynomial and rational inequalities. So let's warm it up by reviewing how to find the domain of a rational function. So anybody remember? Good. We have to figure out the values to exclude by finding out what zeros the denominator. So basically, 4x squared minus 1 cannot be equal to 0. So 4x squared cannot be equal to positive 1, adding the 1 over. Dividing by 4, x squared cannot be equal to a quarter. And square rooting both sides, we would get x cannot be equal to plus or minus 1/2. So let's put the domain in interval notation because the results for this particular section are going to be in interval notation. So the domain is everything except plus or minus 1/2. So we go infinitely to the left, and we have an endpoint at negative 1/2, union negative 1/2 to positive 1/2, union 1/2 to infinity. So if you get a little confused by this, just think of it this way. If you had made a number line about x, the values you found to exclude were negative 1/2 and positive 1/2. And so if you were doing kind of an open circle thinking, you'd be excluding these values for x, but everything else on the intervals would be fine. So you have, that's kind of the number line that can go with this solution. Okay. All right, so now that you're all warmed up, let's go ahead and we'll just review the steps for solving. There's a couple extra steps from what we did earlier for quadratic inequalities. You want to make sure you write the inequality so that a polynomial or a rational expression is on the left side and 0 is on the right side. In one of the following forms, you'll either have f at x is greater than 0, f at x could be greater than or equal to 0, f at x could be less than 0, or f at x could be less than or equal to 0. Now, for rational expressions, you have to make sure, after you do all this work and find the result, you need to exclude whatever zeroes out the denominator. All right, so the easiest way to figure all that out is to get a single quotient, so one happy fraction on one side of the inequality and 0 on the other, and then find out what the domain of f is. At the very least, figure out what values you would need to exclude from your solution. Okay, next up, determine the real numbers where your zeros are. And if the expression is rational, the real numbers where f is undefined. So by figuring out the domain, you would have also figured this out. Use the numbers that we find in step 2 to separate the real number line. So remember, this is the real number line about x into intervals. Select a number in each interval and evaluate f at the number. If f is positive, then every single number, every single function value or y value on that number, on that interval rather, will be positive. If the value of the function is negative, then all function values or y values will be negative for all the x inputs in that interval. So if the inequality is not strict, meaning you could have a greater than or equal to or less than or equal to, you would include the solutions of f of x equal to 0, so the zeros of the function that are in the domain of f in the solution set. And then, of course, be sure to exclude values of x where f is undefined. Okay? So the best way to learn these is by practice. So we have, I think I gave you 4 practice problems. So it's up to you. You can either pause the movie and try them yourself and see how you do, or you can just follow along with me. I will be requiring you guys to solve on exams, you'll have to be able to solve these algebraically as well as with your graphing calculator. So make sure you know how to organize your work. Okay, so here we go. Step 1, do you see, is already done. We have a polynomial function on one side of the inequality and 0 on the other. So I'm just going to rewrite the left side as f of x equal to quantity x minus 5 times x plus 2, the quantity squared. Now remember, our second job is to find the zeros. So set f of x equal to 0. And lucky for us, this was already factored, so it's easier. So we'll get x minus 5 is 0, or x plus 2, the quantity squared, is 0. So x is equal to 5 when I add 5 to both sides. This guy, if I square root both sides, do you see I'll just get x plus 2 is 0. So we'll get a solution of x equals negative 2, which, by the way, has multiplicity of 2. Good. Okay, so we found our zeros. Next step is to make a number line. And then we use our zeros because there's no undefined values in this polynomial. So we're just going to divide it up like this. So we had 2 solutions, so we end up with 3 intervals. So 5 to infinity, negative 2 to 5, and minus infinity to negative 2 are the intervals. Now I'm going to go ahead. We can end up with a lot of numbers going on. So let's see. I'm going to highlight our zeros in this blue here. And then when we get into rational inequalities, we'll highlight those in another color. Now, the numbers we're going to use to test, we'll just put unhighlighted. So what would be a good number here? Great, negative 3 is good. And, okay, 0 is easy in this guy. And then how about 6 here? Perfect. All right, so let's rewrite our function so we can see it while we're testing these numbers. So f of x was equal to x minus 5 times x plus 2, the quantity squared. So when I evaluate f at negative 3, I will have negative 3 minus 5 times negative 3 plus 2, the quantity squared, which is negative 8 times, that'll be negative 1 squared, which is just 1. So we get negative 8, which is less than 0. So we'll put a negative here. All right, so next up we have f at 0. Oh. So f at 0 will be 0 minus 5 times 0 plus 2, the quantity squared. So that will be negative 5 times 4, good, which will be equal to negative 20, which is less than 0. Now let me double check No, we're good on our other interval there. As a lot of times it will go plus minus, but not always. So we'll double check our work using the graphing calculator. All right, so here we had negative 20, so that was less than 0. I put that in. So we get another negative here. All right, so let's take a look at f at 6. F at 6. So f at 6 will give us 6 minus 5 times 6 plus 2, the quantity squared. That's going to be 1 times 8, which is 8, which is greater than 0. So we'll get a plus here. So if I didn't miscalculate anything, then our solution set, remember that this was greater than 0. So our solution set would just be the interval from 5 to infinity. Okay, so we got that from there being a positive right here. So our solution would be from 5 to infinity, non-inclusive because there wasn't an or equal to. Okay, so let's just double check our work here by using our graphing calculator. So here we go. And we'll clear this stuff out. And we had, what was it, x minus 5 times x plus 2, the quantity squared. All right, so let's see. Let's try Zoom standard first off. Okay, we're almost there. Let's go ahead and go to the window. We want the Y minimum to be smaller. Let's try 20 and see if we can see the whole picture. Not yet. Try 40. Wow, it's really low, isn't it? I think we're getting there. We'll try, let's just try, we'll just do 80, negative 80, and I'm going to, I'll increase the scale to 5 for Y. There we go. Okay, so anyway, this is a cool looking graph here. As remember how we mentioned the fact that we had a multiplicity of 2. And so remember, if you have an even multiplicity, you touch the axis. So that is why on this one, so we got our zeros of our function. We're at negative 2 and at 5. So this had a multiplicity of 2. So that was at x equals negative 2. This is x equals 5. And so our solution set is going to be all the values of x for which the function is above the axis. So do you see it's all of these values of x because our function values are above the x-axis only there. Everywhere else the y values are negative, so they're excluded. All right, so we're good to go. Okay, so next up we have, let's see what we have. What other fun stuff is there? Okay, great. Part B, another polynomial. So step 1, what do? Awesome, we have to subtract 9x squared from both sides so that we get 0 on one side of the inequality. So f at x is equal to x to the fourth minus 9x squared, or if you want, you could think of it as f at x is x squared times x squared minus 9. That'll make it easier to find the zeros. You could continue to factor it, or you could just use the square root property when you find the zeros. So, second step, find the zeros. So I'll use the second version here. So we'll get x squared is 0 with multiplicity, or x will be 0 with multiplicity 2, good. And then x squared minus 9 is 0, which gives us x squared is 9, so x squared will be plus or minus 3, or not x squared, x, once I square root. So let me show how I square rooted both sides. All right. So thirdly, we make our number line. And our number line will have, let's see, -3, 0, and 3. And that breaks up the real line into 4 intervals. So of minus infinity to -3, -3 to 0, 0 to 3, and 3 to infinity. And let's see, we were going to highlight our x values, our zeros in blue there. So now we need to pick test numbers. So what do you think? Yep, -4 will work. How about -1 and 1 and then 4? So f at x was equal to, I don't know, we could just use x squared times x squared minus 9. So f at -4 will be -4 squared times -4 squared minus 9. So we will get 16 times 16 minus 9 is 7. And that's something that is positive, 112, which is greater than 0. So we'll put that in here. So now we have f at -1. Actually, yeah, we'll just go in order. F at -1 is -1 squared times -1 squared minus 9. That's going to give us 1 times -8, which is -8, which is less than 0. Now, if you guys were very observant, you may notice that you're going to get the same values for +4 and +1 because the negative was squared away. So this guy we can actually say is going to be equivalent to f at 4. And this guy is going to be equivalent to f at 1 because we have an even function. Now, if you didn't see that, that's okay. You would go through and evaluate f at 4 and f at 1, and you'll find that you would get the same results. Okay? So I'm going to take the shortcut route for me. And so this was step 4, by the way. So let's see. Our solution, remember it was a less than 0 situation. So we are going to take the negative solutions. So we're going to get, for our answer, we will get -3 to 0 union 3 to infinity, because those were the intervals about x where we got negative results. And let's check it using our graphing calculator. All right, so we had x, we'll just do the original, x to the fourth minus 9x squared. And so x to the fourth, or the non-factored version, minus 9 times x squared. Actually, let's get our y values. Let's go to trying to zoom standard and see. Okay, so get our window a little bit lower on the y min. Try 30. There we go. Okay, so here we are. So this was our graph and from the graphing calculator, and notice that the y values that are negative are these guys here. So you can see how that multiplicity of 2 at x is 0, it just touches the axis and bounces back down. So our x values that are negative are going to go from here to here and here to here. And then our zeros that we were using, this one was x equals 3. This was x equals 0. And this guy was x equals negative 3. Okay? Cool, cool. All right, so next up we have now a rational inequality. So just a couple more problems and you'll be free as a bird. I don't know what time it is when you're watching this, but maybe you could do a few math problems for the homework and then go have a margarita or something. Woohoo! So here we are. First step, we want to get 0 on one side. And we're going to have to make this one happy fraction as well. So if we subtract 3 divided by x plus 1 from both sides, we get this inequality. Now we need to get a common denominator. So the 5 is missing a factor of x plus 1, and this fraction is missing a factor of x minus 3. So we're basically getting the LCD on both sides, or for the fraction. So this is going to give us 5x plus 5 when I multiply it out, minus 3x, the minus, a minus changes it to positive 9, all over x minus 3 times x plus 1, and that's all less than 0. So then we'll have 2x plus 14 all over x minus 3 times x plus 1 is less than 0. So f of x is equal to, I'm just going to keep it as 2x plus 14 over x minus 3 times x plus 1. So that's step 1. In this case, step 1 was the harder part. So now let's talk about x values we're going to have to exclude. Do you guys see that x cannot equal to, if I put 3 in there, I would get a 0, and if I put negative 1 in there, I would get a 0 in the denominator. So these have to be excluded, so excluded values. Now excluded values are excluded from the solution but not from our number line. So we're going to put those on our number line so that we know to divide our interval using the vertical asymptotes. All right, or excluded values, however you want to think about it. So second step is finding the zeros. So this will actually be pretty easy. So we'd have negative 2x is 14, so x is negative 7. So our number line is going to be made up of the excluded values and the zeros. So negative 7 is our 0, and then we'll have what? Negative 1 and 3. So we have minus infinity to minus 7 is an interval, minus 7 to minus 1, minus 1 to 3, and 3 to infinity. Now, negative 7 is our 0, right? And these guys here, I'll just write, this doesn't really highlight, does it? Negative 1 and 3, maybe a little. Those are excluded values, okay, because they zeroed out the denominator. So notice that in this case, it doesn't really matter because we just had a less than inequality. But if we had had a less than or equal, it would really matter. Okay, so part 4. Remember that f at x was equal to 2x plus 14 divided by, what was it? X plus 1 times x minus 3. And what test values should we use? That sounds good. We can do negative 8. We could do negative 2 here, 0 here, and 4 here. So starting with f at negative 8, we'll get 2 times negative 8 plus 14 divided by negative 8 plus 1 times negative 8 minus 3. So this is going to be negative 16. Actually, we can just put the result. Negative 16 plus 14 is negative 2. And then we'll have negative 8 plus 1 is negative 7. So we'll have negative 7 times negative 11. So that'll give us negative 2 over positive 77, which is greater than 0. So we put a plus sign in this interval. Okay, f at negative 2. Well, we won't have room there. F at negative 2 will be 2 times negative 2 plus 14 divided by negative 2 plus 1 times negative 2 minus 3. And we'll have that is equal to negative 4 plus 14 is positive 10. And then we'll have a negative 1 times negative 5, which is 10/5, which is greater than 0. Sorry. Oh, you know what? I apologize. I was looking at my work back here. Remember, you're supposed to stop me when I make up my own math. Look at what I did down here. I said that negative 2 over 77 right here. Negative 2 over 77 is certainly not greater than 0. I'll change it here. This is less than 0. So we would have bad teacher. We would have a negative here on that one, okay? My bad. All right. So now f at 0 is going to give us 2 times 0 plus 14 over 0 plus 1 times 0 minus 3. So we'll have positive 14 over 1 times negative 3 is negative 3. So that's less than 0. And then f at 4 will be 2 times 4 plus 14 over 4 plus 1 times 4 minus 3. So that's definitely going to be positive, but completing it out a little more, this would give us 8 plus 14, which is 22. 5 times 1 is 5, so that is greater than 0. Very good. Okay. So now our solution, so recall that our inequality was less than 0, and so our solution is going to be the negative results. So we'll go minus infinity to minus 7, union -1 to 3, all non-inclusive because of the less than and the fact for the right side that we had excluded values. So let's see if our graph agrees with us. So go back to our y equals, and we had quantity 2 times x plus 14 divided by, now you got to put the whole, you have to put an extra parentheses down there so that that whole product is in there. So we had x plus 1 times x minus 3. Oops, I put that parentheses the wrong way. And then we have to put an ending parentheses at the end. Okay. Very nice. Let's go ahead and go to Zoom standard. So there you see our vertical asymptotes, and so you can see a good picture of our graph. And we were taking the, we had a less than inequality. Let me see how I entered in this graph. Yeah, no, are we good? No, because in this instance, our inequality is, our negative part is down here. Let's go back and see what we did. On our, let's see how I entered this in. 2x plus 14 x plus 1 times x minus 3. You know, I'm thinking that we need to get a closer picture in our graph at -7. So let's trace. I want to go over to because at x is -7. So you know what? Let's do this. Let's zoom box this. I want to see what's going on. Kind of an interesting graph, isn't it? So I'm going to go up here, hit enter. I want to see what's going on with the parts of interest because our negative, you know, 1 to 3 is showing up nicely, but not the other one. So I just wanted to get a better picture here. What's going on? Okay, so we'll just we'll zoom in here. Oh, after all that, criminies. Okay, zoom. I was supposed to hit enter. Zoom enter. Okay. Actually, I can start here. Enter. And we'll go up. Over. Yeah, at the end of zoom box, you hit enter, not graph. See, for some reason, it doesn't really seem to be showing. So I'm going to go to the table and see what we have going on. So we have our 0 at -7, and it looks like, so at -8 it's negative. So I see what's happening. It's getting, it crosses the asymptote and goes underneath. How interesting. Okay. So anyway, I'll copy this table so you guys can see and get a look for that, since it wasn't super apparent on the graph. It just dances really close down to the to below the x-axis. And you know what? If I was solving this by graphing, I would have missed it. I probably would have missed that part because it would have looked positive to me on the graph. So that's good to know. All right, so here we go. Our 0 was at, let's see, this is 10, 9, 8, 7. So our 0 was at x is 7. And then our vertical asymptotes were at x equals -3, I believe, or -1. And at x equal to 3. Those were the vertical asymptotes. And the other one was our 0. So basically, it looks like what happened here was this is all negative. This is all negative here. Until you get to 7. All negative. And then right here, as you can see, this is more apparent. The y values are all negative. And so our graph apparently is just kind of dancing right under here, right under the asymptote. And then over here, you can clearly see it's negative. Okay, so our last problem of the day is this guy. So I know it looks kind of mean, but actually it's not so bad because it already has one happy fraction on one side, and it's already factored. So I don't think it'll be as bad as you think. So here we go. Step 1 is already done. So let's just let f of x equal to this whole thing, x times x squared plus 1 times x minus 2 all over x minus 1 times x plus 1. And then what are we excluding? Good. We can't have a plus or minus 1. So those are excluded values. All right, second up, we need to find the zeros. So the zeros will be when the numerator is 0. So x is 0, or x squared plus 1 is 0, or x minus 2 is 0. So x squared is -1. We throw that out because it's an imaginary solution, and we're looking for real zeros. Here we'd get x is 2. So our excluded values are at plus or minus 1, and our zeros are at 0 and 2. So when we make our number line, we're going to use all of those values. So our number line is here. So we said at plus or minus 1. So it looks like we'll have something like this: -1, 0, 1, and 2. Okay, so here we go. testing, we'll have, remember f of x was equal to x times x squared plus 1 times x minus 2 all over x minus 1 times x plus 1. All right, so let's see. This is an excluded value, those two, and these are zeros. So we do have a greater than or equal to situation, so we can include 0 and 2 if they're part of the correct interval, part of a positive interval, but not -1 or 1. So what should we test? How about -1/2? Nope, let's just do -2 there instead of halves. The half will be in that other one. How about -2, -1/2, +1/2, 3/2, and 3. So you might want to use your calculator for this one, or if you want to practice your fractions, you can work it out by hand. I think we'll just do the calculator. So f at -2 will be okay, so we have parentheses -2 times -2 squared plus 1. That's one quantity there. And then times -2 minus 2 in the parentheses for that numerator, and then divided by parentheses, -2 minus 1 times -2 plus 1. Okay. So I get for that one approximately 13.3. So that's greater than 0. So we get our plus here. Now, f at negative, let's write it as -0.5 since we're doing the calculator. So that'll equal to, go back here, and we'll go second entry so we don't have to do everything. We are going to have to do an insert there though. We'll have to go insert and almost there. One more. Oops. Okay. And that one I got approximately -2.1, which is less than 0. All right, now just a few more. So now we'll do +1/2. So this will be fairly easy. We just delete the negatives on the 0.5s. Okay, and we're good. That gives me 1.25. So f at positive 0.5 is 1.25, which is greater than 0. And then now we have f at 1.5, right, or 3/2. We'll say 1.5, probably be easier on the calculator. So let's see what we get. Whoops, second entry. So now we're going to just have to insert a 1 on each of those. 1. Not there though. Let's see, delete. There we go. Okay, so let's see what we got. I got negative 1.5, negative 1.5, or no, what was it? Negative 1.95. So we get a negative, and now doing f at 3 will be our last one. Enter. So 3. Okay, so entering this, we get 3.75, which is greater than 0. That one was less than 0. All right, so now we got to pick our solution. So it was a greater than or equal to. Now we don't include the -1 or the 1, those red highlighted ones. So our solution set will go from minus infinity to -1 with a parenthesis. We're not including -1. Union, the other positive interval, is 0 to 1. So actually we can include 0. So that's why we put the bracket. That means 0 is a solution. But we don't include 1 because that was at the vertical asymptote. And then our last one will be union. We include 2 because 2 was a 0, and we go to infinity. And remember, positive infinity and negative infinity always have parentheses around them. Actually. Okay? All right. So now we'll just do the graph to check our work, and then you'll be all done. So let's see. Clear all that out. Go to y equals, and let's clear this. So parentheses, our original was x times x squared plus 1 times x minus 2 So I end the parenthesis on the x minus 2 and then end the parenthesis on the numerator, then divided by, open parenthesis on denominator, and now open parenthesis on x minus 1. And we'll do x plus 1. All right. Let's zoom this one standard and see. We can zoom in a little bit. Nice. Okay, so this is our picture of our graph. Okay, so here we are. So we had the real zeros were at this one here, x is 0, and then 1, 2, this looks like it's 2, x is 2. We were looking for when y was positive, and here we have our asymptotes, that is x equal to -1, this is x equal to 1, and then our interval about x, where this works, goes here to here, and then here to infinity. Pretty awesome. Okay. So that wraps it up for today. We'll be starting on really fun stuff. Tomorrow we'll be starting on composite functions. We're going to do transcendental functions like exponentials and logarithms and all that good stuff. So have a fabulous day, and I'll talk to you soon. Bye.